This video is going to go in conjunction with 13.2, and it's going to focus just on the unit circle. So forgive my semi-lopsided unit circle here, but you'll get the same point. So this is all going to be on that timed memorization test. I'm going to break it down so that it is cleaner and a little neater for you. If you want to do it on that sheet with the multiple circles, that's great. If you want to put it all into one, that's great. So first we're going to talk about the degrees and the radians and how those work. Now remember, the easiest thing to do is to do our degrees and radians. So obviously we start at 0 and all the way around is 360. Now if you just work your way around, this first red dot right here is obviously 90. Halfway around the circle is 180. 3/4 of the way around the circle is 270. Now if we start going here, this green dot is 30 degrees. Now if I think about drawing this angle in of 30 degrees, I have corresponding green angles or green dots all the way around this circle. And those are 30 degrees. So if I go down 30 degrees, this one is 330. If I'm at 180 and I go up 30 degrees, I subtract, this is 150. And if I'm at 180 and I go down 30 degrees, I'm at 210. So now I'm going to clean mine up a little bit. Take these out. And then we're going to look at the next set of dots. If I look at this dot right here, that's 45 degrees. Well, its matching angles are all the way around here. So if I go up 45 degrees from 180, I'm at 135. If I go down 45 degrees from 180, I'm at 225. If I go down 45 degrees from 360, I'm at 315. So I'm going to get those marks off. And then we're going to do the same thing for the blue dots, which happen to be 60 degrees. So this angle right here is 60. So that means that this angle is up 60 from 180, which is 120. This angle is down 60, which is 240. This angle is down 60 from 360, and so it's 300. So now we have our angles measured all the way around. We could go ahead and do our degrees to angle conversion, which remember is take your degrees over 1 times pi over 180 to get your radians. We could do that all the way around. But there's a little bit simpler way to think about it. So I'm going to do my radians all in green here. So we said that all the way around the circle in radians is 2 pi. So if I think about going halfway around the circle in radians, half of 2 pi is pi. So 180 and pi are exactly the same. That's what we see right there in that ratio. If I think about going 1/4 of the way around the circle, so I have 1/4 of 2 pi, which is going to be pi over 2, and that's what 90 is. And I can continue doing that. If I think about going 3/4 here at the bottom, what's 3/4 of the whole circle, which is 2 pi, cancel, and we end up with 3 pi over 2 is the same as 270. Now come some interesting parts. And if you were noticing when we did our angles of 30, remember that matched up all the way around. So what is 30? Well, let's do our conversion. So 30 over 1 times pi over 180. That cancels and leaves 6. So it's pi over 6. So 30 and pi over 6 are the same. So that means if I go up pi over 6 here, that means I'm going down pi over 6, up pi over 6, and down pi over 6. So let's do some quick conversions. Pi, in order to deal with the fractions, we have to think about that 6 pi over 6 is the same as pi. What is 2 pi if I make a common denominator? Well, it's 12 pi over 6. So if I went up pi over 6, I'm good. If I'm at 6 pi over 6 and I go up pi over 6, we subtracted 30 from 180. We're going to subtract pi over 6. That makes this 5 pi over 6. We added 30 to go here, so I'm going to add pi over 6. That's going to give me 7 pi over 6. And over here, I subtracted 30 from 360, so I'm going to subtract pi over 6 from 12 pi over 6, and I'm going to get 11 pi over 6. So I'm going to go through and I'm going to do the same thing then. Let's get rid of these marks. And let's do 45. So that means we're looking at these angles all the way around. Well, what's the conversion for 45? 45 over 1 times pi over 180 gives me pi over 4. So 45 and pi over 4 are the same. So that means I'm going to go up pi over 4, subtract pi over 4, add pi over 4, subtract pi over 4. Well, what's my equivalent if I need to talk about it in terms of fourths? That's 4 pi over 4. That means that this is 8 pi over 4. So pi over 4. If I'm at 4 pi over 4 here and I go back pi over 4, that puts me at 3 pi over 4. If I'm at 4 pi over 4 and I go down 4 pi over 4, that puts me at 5 pi over 4. If I'm at 8 pi over 4 and I go down, I subtract, that puts me at 7 pi over 4. So let's finish what we're doing with $60. So here's 60 and its angles. So I'm going to go down here and do 60 over 1 times pi over 180. Well, now I'm talking about pi over 3. And so 60 is pi over 3. Well, what is my reference points? Well, that would mean this would be 3 pi over 3, because that's still 1. That means this would be 6 pi over 3 to make 2 pi. So if I'm going back pi over 3 from 3 pi over 3, that means this is 2 pi over 3. If I'm at 3 pi over 3 and I'm going down an additional pi over 3, that puts me at 4 pi over 3. And if I'm at 6 pi over 3 and I go back pi over 3, that puts me at 5 pi over 3. So knowing those degrees and those radians is half of your timed test, your memorized timed test. But if you notice, they all repeat in that pattern based on this first quadrant and then your key reference points. So if you know the first quadrant, you know these three right here, and you know your crosshairs, each of your pivotal points there, you can fill the rest of the thing in with your fraction work. Now, what does this have to do with Sohcahtoa? Now, if we talk about, just for a moment, working on a grid and a point right here, we go over our x coordinate, and then we go up our y to get our xy. This unit circle is a special circle with a radius of 1, and it is sitting on a grid system of x, y coordinates. So what we're going to do is we're going to go through and figure out what those x, y coordinates are for each of the key points. Now, we're going to start again with our 30 degrees right here, and I'm going to build in a right triangle, and this is 30. We've already determined this is a 30-degree angle. Now, if this is a unit circle, that means the hypotenuse, which is the radius, is 1. Let's call this length x and this length y, and that corresponds on our coordinate system of going over x, up y. I'm going to figure out what the xy coordinates are for right there. I'm going to do this off to the side. 30, if I want to find x, that's the adjacent and the hypotenuse, I'm going to have the cosine of 30 is equal to the adjacent over the hypotenuse. Go to your table. What is the cosine of 30? The cosine of 30 is the square root of 3 over 2 is equal to x. That's the x coordinate. I'm going to repeat the process. What is sine? It's opposite over hypotenuse. So the sine of 30 is equal to y over 1. What's the sine of 30? 1/2. There's your y coordinate. So really what we found is that your x coordinate is the square root of 3 over 2, and your y coordinate is 1/2. And that corresponds to, you went over x, that long side of that 30, 60, 90, you went up y, the short side of that 30, 60, 90, and that gives you your xy. Now here's where it's interesting. If you think about a coordinate system, in quadrant 1, your x and your y are both positive. In quadrant 2, your x is negative, your y is positive. In quadrant 3, your x and your y are both negative. And in quadrant 4, your x is positive and your y is negative. That's exactly what's going to happen if we go back to those same angles we drew. Here's that 30-degree angle here. Here's the 30-degree angle. And here's the 30-degree angle. So all of these triangles are identical, which means their x and their y coordinate are identical. If you think about it, this is x, and this is y. The only thing that changes are our signs. So my signs here are negative square root of 3 over 2, 1/2. My sign down here is negative square root of 3 over 2, negative 1/2. And my sign over here is square root of 3 over 2, negative 1/2. I will continue filling this in the next part of the video.